peeps, it's Sophie from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're doing the 2018 Grade 10 Physical Sciences paper on energy. So let's have a look at what the question says. It says, a skateboarder starting from the top of a ramp, as you can see here, 4.5 meters above the ground, skates down the ramp, as shown in the diagram below. The mass of the skateboarder and his board is 65 kilograms, and ignore the effects of friction. Great. So as you can see, skateboarder will come down here, down this whole ramp, and reach the bottom, and this is floor level. So let's look at what question 5.1 says. It says, define the term gravitational potential energy in words. So that I've written here, and it says that gravitational potential energy is the energy that an object has based on its position in a gravitational field relative to some reference point. So the reference point is an important thing because it depends on where you're looking at it. So from the ground here, if that's your reference point, then it's whatever gravitational potential energy this skateboarder has relative to the ground or relative to something else. It always has to have some reference point. Okay, the second question is calculate the gravitational potential energy of the skater just before he skates down the ramp. So whenever there is no movement, there is zero kinetic energy. But now, because he's at the top of the ramp, his potential energy is at a maximum. His gravitational potential energy is at a maximum. So we know the formula, and that is the gravitational potential energy, I'll call it E sub P here. That is mass times gravitational acceleration times vertical height. It's always a vertical height. It's never a slanted height. It's always the vertical distance down, the perpendicular distance down. And okay, so now we can just substitute in exactly what we've been given. So we've been given that the skateboarder and his board are 65 kilograms. That we know that the gravitational acceleration on Earth is 9.8, and we know that their distance is 4.5 meters. So that gives you an answer of 2,866.5 joules. The units of energy is joules. Okay, so that's his gravitational potential energy. And we've chosen down as positive, which means that, the reference point is in the positive direction, which means that that is a positive energy value, although energy is a scalar, so it doesn't actually require a direction. So then 5.3 says, state the principle of the conservation of mechanical energy in words. So I've written it on the pink sticky note here, as you can see. So it says the total energy, so it says gravitational potential energy plus kinetic energy. So that's saying that the total energy always consists of the gravitational potential and the kinetic energy at any point. And an isolated system is conserved. So I was saying earlier that this guy has a maximum potential energy at the top. That's because his kinetic energy is zero. Energy is always EP plus EK, always, mechanical energy. So the next question says, use the principle stated in question 5.3, so the conservation of energy, to calculate the magnitude of the velocity of the skateboarder when he reaches the ground at point X. So let's go. So 5.4. Okay, so we know that energy is conserved, and I've said in the pink sticky note that energy, total energy, is the potential energy, gravitational potential energy, plus kinetic energy at any point. So we're going to do at the top of the ramp. But because it's conserved, that is also equal to the same term, potential energy plus kinetic energy, at the bottom of the ramp. So here in this area there. But We now know that at the top of the ramp, because he has no movement, his kinetic energy is 0, but his potential energy is at a maximum. So we know that at the top of the ramp, we know that it's mgh plus 0, because we know he's not moving. And then at the bottom of the ramp, he's going to have no potential energy because he's at the bottom where our reference point is. So there's no distance that is the difference from our reference point. So there we're just going to have our kinetic energy term and no potential energy term. So that kind of makes sense. He's going to have his maximum speed and energy as he comes all the way down the ramp, and he's going to lose energy as he comes up as he gains potential energy. So doing that calculation, so we know that his, well, we can use the same value over here. So we know that 2866.5 is equal to a half times 65 times velocity squared. And you can work out his velocity, and that gives you 9.39 meters per second. So that's the velocity of the skateboarder at point X. So then they ask, will the skateboarder be able to reach point Y if he were to remain on his skateboard? Write yes or no and support the answer with a relevant calculation. So what they mean by remain on his skateboard is that he's not going to add any additional energy. He's not going to run up. He's not going to walk himself up. Will his energy take him to the top of the ramp? And now if you think about this, if he's got enough energy to travel up 4.5 meters, will he have enough energy to travel up 6 meters? I don't think so, but let's see what the math says. Okay, so let me make some space for all of this. Okay, so let's see how we should work this out. So we take the same approach. You know that the potential energy plus the kinetic energy at the bottom of the ramp, or at point X, is equal to the potential energy plus the kinetic energy at the top of the ramp. So what we're going to do is we're going to calculate what height he can get to with the energy he has, and we're going to see if that is less than or more than or equal to 6 meters. So let's get started again. We know that at the bottom of the ramp he only has kinetic energy, and we know his velocity. So potential energy at the bottom of the ramp, this is at point X, is 0. So let's go a half times his mass, which we know is 65, times his velocity, which we just worked out, is 9.39, and that is squared. And then at the top of the ramp, we know that he'll only have potential energy because he's not moving anymore. He's run out of energy. If he's at a height, his potential energy is going to dominate. So his kinetic energy is 0, and we know his mass, and we know his gravitational acceleration. Then we can find his height. And then if you solve that, you get a height of 4.49 meters. Which makes sense. That's what we explained. If he had enough energy at 4.5 meters with no kinetic energy, then he'd probably only be able to go that distance with the energy that he had, because he can't create or destroy energy if he's not putting energy into the system, which he's not. So the answer is no, he cannot travel 6 meters because 4.49 meters is smaller than the 6 meters that he would need. So that's question 5, the conservation of energy. Well done. Before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible, and you can read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos, and if you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. But until next time, stay epic.